All right, let's go ahead and get started. So I've sent you 3 files: a Jupyter Notebook file, a Python script, and a comma separated value CSV file, which is where all the data lives. Okay. So this tutorial demonstration implies, one, you know how to run Python. You might not need much experience, but you know how to do it, or you have someone in your office that knows how to do it and they can guide you through it. But I'm going to try and make it as simple as possible. Oh, number 1. So hello. You open the file, and then sorry, I got distracted. Open the file into Jupyter Notebooks and you run it. Okay, so let's just open it here. So I just opened my IPYNB file, your Jupyter Notebooks file, and it looks like this. Got all these different cell sections that do, each section does something, right? Each cell section has a title. What's it doing below here? Okay, what's all this stuff doing? Like, for example, here's where we calculate percentile thresholds right here, okay? All right, but to prove this is super simple, all you're going to do is enter 5 easy things. Number 1, column header from the data file, Tmax and whatever station it is, right? All of your options I've already written right here. These are all of the column files in your spreadsheet that I'm giving you. Okay? So you got to choose one of these to enter here. Okay, simple. You want Tmax at Grantley Adams International Airport? Well, type in Tmax _ GAIA, exactly how it's written here. All right. So you're making some plots, and it has a plot title. What do you want to call it? Station name? Well, type it in here. Station name is CIMH. Maybe the station name at some places will be Manly Airport. Maybe the station name will be Dominica Canefield. You just type in the station name here, however you want it to say. What year do we want to look at? What time series year do we want to look at? I don't know. You want to look at 2000? 2000? You want to look at 2020? What? 2020? Whatever you want to, whatever year you want, just type it in here. Between 1991 and 2023. Okay? This last part, you only change this when you update your CSV file with most recent daily information. Right now, I only have data that goes up to the end of April. Pretty soon, we'll get data that goes up to the end of May. I will then change this once I update the data file as 2024-05-31, just to have the latest going up to May of 2024. And the final thing you enter is just the path name and your name of the CSV file. Here's where it lives for me, and I'm calling it multi-station daily max min temps blah 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 CSV blah blah blah. All right, so that's all you do. Prove it's that easy. You can go to kernel, restart and run all. Okay, let's do it. Give it a second. Boom, that bottom one shows up. Let's scroll to the top. Okay, just a simple version. Let's look for the plots. Boom, there's one, first one. What do we got here? Daily maximum temperatures at CIMH during 2020. How did I know that? Well, look, Tmax CIMH starts at 2020 at CIMH. This is the title, the name in the title, CIMH, right? To prove it, it's right here. If I wanted to say at whatever, at Teddy's house, I would have typed in Teddy's house up there, and it was showing up here. All of the dates for the legend are updated automatically. So here we have daily Tmax for 2020 at CIMH. All these symbols are representing the legend. The black thick line is the climatology, your daily average. The oranges are days above Tmax, above the daily average Tmax. Blues are days below the daily average Tmax. Your pink dots are the daily records from 1991, daily Tmax records for each day of the year. The filled in, the ones with the black outline, show where that daily record was set in 2020. So in 2020, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days. 11 records were set in 2020 of the daily Tmax at CIMH. Right? And these are your minimum, your record low Tmax, blah, blah, blah. Okay? Now, and red is where it's above the 95th percentile. The 95th percentile is this dashed line. I like this a lot until I realized, you know what? These oranges here get the same amount of attention as these oranges here. Okay, and I didn't think that was right. I didn't think you should be able to look at this and be like, oh, it's above average here. Oh, it's also above average. It's a lot more above average here. Let's take that into consideration. I'm going to scroll down a little bit. I'm going to ignore that one. This, I think, is much better. It's the same thing, but instead of having everything orange and everything blue, it's now a graduated color scale, right? So graduated positives from like a white to a burnt red, and like a white to a freezing cold blue, right? So now you can better understand, oh, look, yeah, that wasn't very much, even though it's more than normal, it wasn't that much more than normal, right? But a few days later, whoa, yeah, it was warmer than normal. It was close to, more than a degree more than normal. How do you know that? Well, the color says that, but also that's about 29 and a half. And that day was about 30 and a half. So yeah, about a little more than a degree. Anyway, you see how this works, right? I personally think this is better. And as a cool thing, added bonus, you indirectly calculate the daily anomalies too. Because remember, all we're doing is plotting Tmax. Before, you could only say, oh, here's your Tmax, it's above average. And I could tell you what the Tmax is by looking at it, by reading the scale. Here I can say, yes, it's above average, and it's a lot more above average here, there, and there. And how much more? We'll look at the color scales. All right? So I like that. Let me know what you think. Would you do it differently? Do you think it's too confusing? Sometimes you can have too much information on a map. Not map, a plot or a map. But in this case, a plot time series. Okay, now we do the same thing, but we're just looking at 2024 year to date. So instead of January through the end of December, it's just January to whatever our most recent data is, and that's late April. And that comes from here. Remember? Last date up here, that's where we type this in, because it's only going to go to where we type in. All right? Cool. It's a little zoomed in for 2024. You can compare to the first part of 2020 or 2023, whatever year you want to compare it to, right? Same thing as above, but now we're using the same graduated color scale. You can look at the year-to-date 2024 in context of what the annual average is. So you know, like, oh, it should be increasing. And you do the same thing. Now, I like this. If I want to save this, right-click, save image as, give it a name, blah, 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 blah. You know how to do that. And all this stuff is customizable. If you want to add something or take something away, or you want the scales to go higher or lower, you can figure that out in the code, or you can just email me and I'll help you walk you through it. All right? So that's that. That's how easy it is. Wait, what if I want another year and a different location? Let's check it out. Let's look at Tmax at, how about, let's look at St. Martin, shall we? There it is. How did I know that? Oh, it's right there. What do I want it typed in the title? The name. Okay. What year do we look at? Let's look at last year. Not changing that. Not changing that. I'm going to kernel, restart and run all. Boom, boom, boom. Give it a second. Boom, bottom one shows up. Excellent. I can scroll up. I'm just going to go to the one I really like. This one. Now, look at this. This is still a good time series because it really shows you where the dates above the 95th percentile are. I like that. But I don't like the way all the oranges are kind of equally weighted here just by visual context. So I use a graduated color scale, but I lose the highlight above the 95th percentile, right? Boom, boom, boom. Now I could have it all red here. Want to see what that looks like? I'll make that quick change. Alpha. I'm just going to run this section here. Hey, you can't really see here. Oh, I did the wrong one, I think. Sorry. Let me change that back. Did not want to do that. I wanted to do it. Here. Alpha, right. There. It describes the opacity or opacity. There. Now you can see it's red. See, I don't really like that. If it's just going to be red, I think that's better. Here, it's kind of like, ooh, what is going on? I don't get this. All right, so that's why I decided not to do that. Put that back here. You can play around with it, so I'm keeping it low. That means pretty much super invisible. Now you can't see it. Anyway, right click, save as. You got it, right? Now what if you just want to use the Python script .py? Well, let's do this. Open Spider. Or whatever you use to look at your Python scripts. I like Spider or the notebook. I'm just going to open up my .py. Let's see, where does it live? It lives in the data analysis folder. Guyana, code, there it is, open. That's it. All I did was copy and paste all those cells into here from the notebook. That's all it is. Instead of having cells running things individually, just here, push play, push run, boom, boom. You get all your plots. You can do whatever you want. You can save plot as. You got it. You know the drill. You look at your variables if you're interested in that stuff. Plots, more plots, everywhere plots. Anyway, let me know what you think. I hope this has been beneficial. Please do not hesitate to let me know if you have any questions. I am not a programmer. I don't pretend to be an expert Python programmer, which I am not. So the code will probably look very inefficient to a lot of people who are good programmers. Feel free to call me out and say, this is horrible, this is garbage, it could be so much better. It probably can. It gets the job done. And that's about that. Okay, hope it works. Thanks.